Good morning, you all, my dear children. I am going to teach you about the chapter 7, equilibrium. In this chapter, I have already discussed in my previous lecture what is equilibrium. Now, I am going to discuss about the law of mass action. What is law of mass action? Guldberg and Vage gave this law. According to this law, the rate of a chemical reaction is directly proportional to product of active masses of its reactants. Consider a reaction is A plus B gives C. In this reaction, A and B are reactants. The rate of reaction is directly proportional to active mass of A into active mass of B. This law states that the rate of a reaction is directly proportional to a product of active masses of its reactants. Okay. Consider a reversible reaction as follows. A plus B gives C plus D. In this reaction, both forward and backward reactions takes place. In forward reaction, A and B reacts to form C and D, and in backward reaction, C and D reacts together to form A and B. Means in forward reaction, the reactants are A and B, but in backward reaction, the reactants are C and D. According to law of mass action, the rate of forward reaction means RF is directly proportional to active masses of its reactants, means active mass of A and active mass of B, or RF equals Kf into active mass of A into active mass of B, where Kf is rate constant for forward reaction. Like this, rate of backward reaction means RB. In backward reaction, the reactants are C and D, means RB proportional active mass of C into active mass of D, or RB equals KBC into D. You know that at equilibrium, the rate of forward reaction becomes rate of backward reaction. So that Kf into active mass of A into active mass of B equals Kb into C into D, or Kf by Kb on cross multiplication, Kf by Kb equals active mass of C into active mass of D upon active mass of A into active mass of B. These both are constants, hence you can write here another constant Kc equals active mass of C into active mass of D upon active mass of A, B. This is the expression for rate constant for this reaction. A plus B gives C plus D. Means the products are on upper side and reactants are on lower side. Suppose that if a reaction is P plus Q gives R plus N, when what will be expression for Kc? What is Kc? Kc is known as equilibrium constant. Equilibrium constant. The ratio of rate constant for forward reaction and rate constant for backward reaction is always constant, and this ratio is known as equilibrium constant. What will be expression for Kc for this reaction? R and S on upper side and P and Q are on lower side. Okay? If the reaction is as follows, AA plus BB gives CC plus DD, small a, b, c, d are coefficients, stoichiometric coefficients, then it becomes in power, means Kc equals active mass of C to the power C, active mass of D to the power D, active mass of A to the power A, active mass of B to the power B. Suppose an example, see here, for this reaction, H2 plus I2 gives 2HI, the equilibrium constant Kc will be square of active mass of Hi into active mass of H2 into active mass of I2. Take another reaction like this, 2NH3. The expression for Kc will be NH3 square upon N2 into H2 cube. Means that is on this side is on upper side and that are the reactants which are on lower side. The coefficients are at the power. This is the law of mass action and method to write the equilibrium constant expression for any reaction. Okay, thank you.